Welcome! We are working on section 2.3, all about inequalities today. So a couple properties of inequalities we'll talk about. As you can see, we have our little smiley face down here thinking. We have to remember about flipping inequality signs, and then we'll get into absolute values with inequality signs. So a lot of things with inequalities coming at you today. A couple properties for us to know and review quickly. Property 1, if A is less than B, then A plus C is less than B plus C. So in other words, if I add a constant to both sides, it's still a true statement. Same thing if I subtract a constant from both sides, the left side is still less than the right side. So a quick example, if x minus 3 is less than 0, then if you add 3 to both sides, it's still the same problem. The next property is if A is less than B and C is positive, then you can multiply them to both sides or divide it to both sides and nothing changes. Notice it says if C is positive. There's an example there for you. However, if A is less than B and C is negative, then when you multiply both sides or divide both sides by that negative, notice your sign flips direction. It used to open to the right. When you multiply or divide by a negative, it flips. Very importante. There's also something called the transitive property. If A is less than B and B is less than C, then it also shows that A would have to be less than C. Okay, we'll look into a couple examples like that shortly. Well, when do you flip the inequality sign? Well, go back to property 2, part B. You flip the inequality when you multiply or divide by a negative value. Okay, make sure you don't forget. It's a very small step. It will completely change your answer in the end. Definitely if we ask you to graph on a number line, the whole opposite side would be shaded if you forgot to flip. Okay, let's solve two inequalities. Solve each of the following inequalities, state the solution in interval notation, and graph, like I said. So here is part A. Part A was 2x minus 3 is less than 5. Add 3 to both sides, divide by 2. This would be my inequality, x is less than 4. We now want an interval notation. Interval notation would be negative infinity to 4, both in parentheses because we're not including. On my number line, I have to make sure I have the number 4. It's going to be an open circle, or if you want to put a parenthesis here, remember the book does parentheses, and you shade where the solution is, everything that's less than 4. Now we're going to solve part B. Part B is 5t plus 8 less than or equal to 7, 1 plus t. What I like to do, notice like this example, I just keep the symbol coming down at each problem. It's pretty much like an equation. You just have to keep in mind what you do to one side, you do to the other. So let's treat part B just like an equation as well, and we'll bring down that inequality sign as we solve. First thing I'm going to do is distribute. I'm going to combine my like terms, which means I'm going to move the 7t to the left. I'm going to move the 8 to the right. The reason why I do that is I like to have my variable first. So you could have written it the other way around with the t values on the right side, but you're always going to see the t values or the variable on the left, and it's actually easier when you go to graph it. So I would like you to keep the variable on the left side. Now I'm dividing by -2. You are dividing by a negative. The moment you do so, write the word flip. I know it's tedious at the beginning, but it's so silly if you forget. So here I'm dividing by a negative. That means my sign flips direction. It's still equal to on the bottom, but the direction of your inequality changes. So now you're left with t is greater than or equal to 1/2. This is an inequality notation. They want us to put an interval. So interval would be a bracket 1/2 to infinity with a parenthesis, because you never put a bracket with infinity. When you graph the number line, make sure you have the point 1/2, close circle, and you shade everything to the right. If you did not remember to flip, your inequality shading would be the other side, which would be everything that's incorrect. Like here again, I just bring down my inequality sign, and don't forget to flip in this case. Now we're going to jump into if we solve a compound inequality. A compound inequality just means that there are 3 areas you're going to have to work with. Normally, what you do to one side, you have to do to the other. In this case, what you do to one side, you need to do to the other 2 sides. You have to make it like a balance. Everything needs to be balanced. So first thing I want to look at, I have fractions. The easiest way to get rid of those fractions is to multiply everything by like -4, right? That least common denominator. I multiply everything. Please note, all 3 parts will get multiplied. That leaves my first one, my first distributing, to be +2. This next one would be 3 minus x. And this next one would be -2. Now, pay attention. You just multiplied by a negative. You need to flip those signs. Boop and boop. Next step, I'm getting x by itself, so I'm going to subtract 3 to all 3 sides. That gives me -1 greater than -x, which is greater than -5. I don't want what -x is. I want x. So I need to divide everything by -1. Notice I'm dividing everything by -1, and I'm dividing by a negative. So flip. Write it down. I promise if you write it down, you will not forget. The signs flip. You now have 1 is less than x, which is less than 5. This is inequality notation. I believe we still want intervals, so I'm going to write that as the interval 1 to 5, parentheses because you're not including. Then when I graph it, I need both of those numbers on my number line. It's an open circle, and it's the values in between. Please, please, please watch that multiply divide by a negative. They'll just slide in there. Next situation we have is with absolute values and inequality signs. There are two cases that we could see. The first one, and I did right here, the absolute value can be less than a. If that's true, it's saying if and only if u is between negative a and a. Which makes sense. We did this on our first day of inequalities. What's in the absolute value could be positive or negative. What comes out will always be positive. So these are the values it could fall in between. Here's a perfect visual to show you. It's saying the distance that x is from 0 is less than 1. So it can go almost 1 in this direction. Remember, it's parentheses, so you can't actually include 1. Or you would be 1 away in that direction. Less than 1, so you could be a half away. Negative a third away, a fourth away. But you'll never be bigger than 1 unit away. So that makes sense why it's inside, it's including. Versus the next case is if the absolute value of u is greater than a. That will give you two cases. It means u will be less than negative a, or u will be greater than a. So let's look at this example. It's saying the absolute value of x is greater than or equal to 1. That means your distance away from 0 could be 1 or more. Okay, you're at least 1 unit away. Then you can keep going and become maybe 4 units away, 6 units away. But it would fall in these two cases based on your absolute value. Sometimes I like to label these like this is case A, this is case B, just as we're getting started, so that we can really visualize what's happening. Are we really, really close to the origin, or are we really, really far away from that origin? So here's an example. Solve absolute value 1 minus t over 2 is greater than 5. It cut out. Sorry guys, this got moved over. What we're going to do is we are looking for all numbers t such that this part that's inside, I'm going to actually change it, such that this part, which is inside the absolute value, is more than 5 units away from 0. Therefore, we are looking 5 units away, more than 5 units away. So this would be case B. Therefore, the solution must be within this interval or this one. Let's solve it and I'll show you what we mean. I'm going to put that this is a B version out here because notice it is the absolute value is greater than 5. So I have these two algebraic cases here. The first one is that what's in the absolute value is less than the opposite of 5, which would be this area right here. That's what I'm visualizing. Or the other case it could be is that the u, or what's in the absolute value, is greater than your a value. Talking about this portion over here. It could fall in one of those two cases. Let's solve each one. I get negative t over 2 would be less than negative 6. I'm going to multiply both sides by negative 2. Look at me, I'm multiplying by a negative. So you're going to flip. I know it's silly, but you'll never forget. Flip your sign. So I end up with t is greater than 12. That would be my first inequality. Or you could have this next situation. negative t over 2 is greater than 4. Multiply everything by negative 2. Okay, we're multiplying by negative. I'm not going to forget to flip. Or t could be less than negative 8. These would be your two solutions. I'm going to now show those on a number line, so I'm going to do that down here. We have the number negative 8, the number 12, zeros in the middle. They're both going to be open circles. I'm going to shade bigger than 12 or less than negative 8. That's exactly what a B version looks like, right? You have those two areas that it could fall in. You have two inequalities, and then you have your number line. If you want to write it in interval notation, if it asks for that, you could write negative infinity to negative 8 and 12 to infinity. The symbol in between, you could put or the other option is a U. That means both of those put together will be your answer choices. But if you're okay, I'm okay with just putting or. Let's try another one. Looking here, absolute value x minus 5 less than or equal to 2. Well, looking at here, this is a case A where the absolute value is less than 2. So it falls into an inequality like so, and it will look like shading one area. So this means u, which is x minus 5, would be between 2 and negative 2. That's exactly what my notes are telling me. Now I have a compound inequality. Luckily I know how to solve those. Add 5 to all three parts. You'll get 3 less than or equal to x less than or equal to 7. Notice I didn't multiply or divide by a negative, so I don't have to worry about any flipping. If they want it in interval notation, here we go. And if we want it on a graph, you have 3, you have 7, both are closed, and you shade in between. And that is exactly what an A version is. You shade in the middle. Try to give the next one a shot. Please pause the video and give this second example a try. Hopefully you paused it and gave it a try. If you got a little stuck, let's go through it together. I'm going to move that 7 over to the other side. Because I subtract, I don't flip. It doesn't matter if you add or subtract a negative, it's when you multiply or divide, which is like this step right here. So make sure you flip that sign. So I'm left with absolute value of 3x plus 5 equals 10. Notice this would be an A situation where the absolute value is less than or equal to a value. So I'm going to have that inequality, and it's going to be a shading in between. That's a way for me to check as I go as well. So it's saying my u value, what's in between, will be sandwiched in by negative 10 and 10. We have a compound inequality. Let's solve. Move that 5 from each side, so you get negative 15. Now we have to get rid of the 3. I'm dividing by positive 3. No need to flip. Do get a little fraction, that's okay. Here it is in inequality notation. Here it is in interval notation. Notice my brackets because I'm including. And then here it would be on my number line. -5, 5/3. Those 2 points at least have to make it on there. Make it obvious that they are closed circles or a bracket on here. And it's everything in between. Hopefully you got that right. If you didn't, let's ask questions during class. Here is your absolute values with inequalities. Good luck, peeps!